Welcome back. Now that we know the need for networks is here, we need to gain an understanding of how computers communicate at their lowest level, their most functional level. Excuse me for a second. I have to take my glasses off for this one. Not really. It's very, very simple the way they communicate. Now, obviously, we'll be talking about IPv4 because we're going to be discussing a little bit about ARP. All right, we'll get more into ARP when we get into the routing process. But you have two computers, as you can see back here, and I'm going to move out of your way. All right, I'll move this to one side, and you guys can see there we got Juan, and you have Maria, right? Two computers there. Those are their computer names. But obviously, these computers, in order to communicate with each other, have to have an IP address. Not only do they have, and that will be considered a layer 3 address, right? And we'll talk about layers later on when we talk about the OSI model. But this is a layer 3. This would be IP addresses. So they will be, definitely need to have IP addresses. And they also have, they also have MAC addresses. MAC, which are, okay, I guess my finger is not on the money there. So this is 192.168.1.1. This will be 192.168.1.2. So, but we have a layer 1 device right here, which is a hub. Now, hubs are not used in today's technology. And let me explain just a tad bit about hubs. Because when Juan wants to talk to Maria, he only knows the name. He doesn't know Maria's IP address, right? We're talking about users. Users don't know each other's IP addresses. So you go searching for Juan, right? Or Maria in this case. You look searching for Maria's computer. So if this is the first time you're doing it, what's going to happen is there's going to be an ARP request that's going to be sent out through this particular layer 1 device. And it's going to flood out as many ports as this hub may have. You have a 4-port hub, you can have a 24-port hub. All right, and this ARP request, this ARP broadcast, which actually does a layer 2 and layer 3 broadcast, looking, hey, who's Maria? Well, I'm Maria. That's my NetBIOS name, which is my computer name. And she will reply and she'll say, hey, that's me. This is my MAC address, right? This is my IP address. So now Juan knows the IP address and knows the MAC address. So he's able to communicate with Maria at that point once he finds that information. Because in order for computers to communicate to each other, they need a couple of things. They need their source IP address. They need their source MAC address. They need the destination IP address, and they need the destination MAC address, plus they need a port number, right? You're going to a destination somehow. You're doing a remote desktop. Are you telnetting in? Are you sending an email? So the way you reach the destination, whatever path you choose or application you're choosing to use, whether it's the browser, whether it's these telnet sessions, or remote desktop sessions, however it is, FTP sessions, TFTP sessions, however it is you're trying to access that particular destination, a port number gets assigned to that. So all that information needs to be there. Well, at first, they don't know that. So that ARP broadcast will give you that MAC address and IP address of the destination computer. Now, the problem is this, because if you look at it, the ARP means Address Resolution Protocol. First, he had to resolve her name, her NetBIOS name. Once he resolves the NetBIOS name, he gets the IP, then he needs to resolve the MAC address. Once he gets the MAC address, boom, now we can go ahead and go across. But the problem lies in the hub. It's a problem with the hub that we're going to get into, definitely, and I just want to mention this right now, just a little bit. A hub is what's called a shared collision domain. It's what they call a multi-port repeater. Remember that repeaters really only have two ports, one coming in, one going out. All they do is they bring in a signal, they regenerate it, they clean it up, and they send it out the other side. So we can extend a network, all right, or whatever it is that you're extending. Hubs are just that. They just have more ports. And the problem with that is that you have only one collision domain, and I know I'm throwing a term at you, one collision domain, one broadcast domain. What that really means is chaos. Chaos. Because the more computers that you plug in to this particular hub, since it's a shared collision domain, what's going to happen is it's going to divide that bandwidth. Now, we haven't talked about cables, but this is a Cat5 twisted pair cable that can have the capability of going 100 megabits per second. The more, let's say you had that 24 ports, and all those 24 ports are now plugged in with nodes or computers. So you got to divide those 24 ports into those computers. You have 5 megabits per port. You just reduced that bandwidth that you're capable of having, because you can only have one set of wires, one pair of wires to send and receive. So what is that called? It's called half duplex. So definitely, just to give you an idea, very simple network, just two computers trying to talk to each other. But you know what? I'm going to take this opportunity to show you. I know we've seen it before, but I'm going to show you again. All right, so you don't forget. I'm going to go to our simulation mode right there. I'm going to get that simple PDU, remember, that we did in the packet tracer. I'm going to put it in Juan's PC, and then I'm going to hit Maria's PC. Again, we get that ARP. And then I'm going to hit that auto capture and play, and we see what happens. There's your ARP. Now that ARP will go out all existing ports if anything was connected on there. Maria says, hey, that's me. Here's my MAC address. I'm going to send it right back at you so you can communicate with me. Once it goes back over there, any day now, well, it's a shared collision domain, so it slows down. And now the ping can go across. And you've seen this before. And you can see it right there that now the ICMP, that is the protocol. Let's go ahead and delete that. All right. So it does the same thing. The problem is, and always remember to go back to real time. The problem is this device right here. You do not want to have hubs in your networks. Now, when we start talking about internetworking devices, and we are, that exist on a network, I'm going to start explaining to you why you want to use these different devices in your network. One of which is because this is considered an Ethernet network, which is an 802.3 standard, which the access method is CSMA CD, which means, hey, there's noise in the wire, I can't transmit, first come, first serve. Think about it. You're sharing the bandwidth across all ports. You have to wait to see if there's anybody transmitting in order for you to transmit. And you can only send or receive because you're using one pair of wires. So definitely this would be a chaos. I always use the example of a hub as, imagine the busiest intersection in the world. Imagine the busiest intersection. Everybody's going 100 miles an hour. No stop signs, no traffic lights, no police officers directing traffic, nothing. Just everybody just running non-stop. There's bound to be a crash somewhere along the line, and this is exactly what happens when we deal with Ethernet. This is one of the issues that we have to face. That's just the way Ethernet is. So one of the things that as networks developed, as you'll see, definitely the hub got replaced because of that one collision domain, one broadcast domain, that all it does, it causes chaos. But once we start learning about the different devices that exist on the network, then you'll start getting an idea, oh, hey, this will be a better device. This is how we're going to segment it. This is how we create those VLANs at layer 2 so we can tweak our network and make it more functional. So I'll see you in the next lecture.